everyone. Yesterday was National Hydrogen and Fuel Cell Day. While I don't think those technologies are specifically required in Title 24, we are going to learn more about the forthcoming changes in California's Green Code. Today we're going to delve into the modifications that are coming, as well as some of the innovative technologies, such as heat pump water heaters, that will help you meet and exceed performance requirements. We're also going to hear successful case studies that contain solutions for reaching both energy efficiency and cost targets. Now, joining us today are Jeff Wicks and Greg Holliday. Greg Holliday is the Business Development Manager for water heater manufacturer Bradford White. He came to Bradford White after 32 years with General Electric, where he introduced the first Energy Star electric heat pump water heater to the U.S. market. Now, some of you might be familiar with the GeoSpring product. Well, since joining the Bradford team in January of 2017, they've acquired the GE GeoSpring plant equipment to fold into Bradford's manufacturing site in Middleville, Michigan. It now goes by the Bradford White name of Aerotherm. Now, Jeff is the Senior Product Manager for NEA's Emerging Technologies Group. He works closely with utilities, trade allies, and trendsetters to identify and prove out innovative, energy-efficient technologies to transform the market. His current areas of focus include heat pump water heaters, pumps, fans, and efficient motors. He has been heavily involved in the rollout of the U.S. DOE rulemaking on efficient clean water pumps. Jeff's background in energy efficiency and demand response has included management in the fields of instrumentation, manufacturing, construction, IT, and utility market transformation programs. Now, during the course of today's presentation, you could submit questions for our guests. Simply use the questions box that's probably on the right side of your screen. I'll convey them to Jeff and Greg after their presentation. Jeff, you're up first today.
Great, thanks, Mike. Jeff Wicks from NEA. I work in the emerging tech area, and we are an interesting organization. We focus on market transformation, where we provide innovative solutions to our funders, and we are funded by 140 utilities here in the Northwest, and their need is to bring good solutions that work in a reliable fashion. So they've asked us to look at one of the most important loads, which is water heating. So you're going to hear a little bit more about that later, but if you have any questions about what we do up here, my contact information is available. Call anytime.
And I'm Greg Holliday with Bradford White. Bradford White is a corporation that's made up of 4 companies and about 1,500 employees, and our vision is simple and remains unchanged. We're to serve the plumbing and heating professional with high-quality, superior products made by American workers. We are American strong, and Aerotherm is one of those products manufactured in Middleville, Michigan. So today, what you're going to hear is a common sense approach. What's going on in Title 24? It's going to be short and sweet as Jeff reviews some of these changes and how important they are. And then we're going to spend some time talking about heat pump water heaters, what they are, what they're not, where they can be used, why use them, and the evolution from gas to electric that is taking place right before your very eyes. Jeff?
So thank you, Greg. And Greg and I work quite closely across the country, and so part of this is what's going on in California, but I'm going to be talking about some national trends. But specifically today, we're going to look at what Title 24 is offering and how this is changing what builders, raters, and consumers are going to be seeing in their building stock over the next period of time, whether that's 5 to 20 to even 50 years. So fuel sources do matter now. It used to be that they were kind of isolated, and there was this whole idea that you couldn't switch fuels, or you needed to have dual fuels in every house. It is now changing to more of electrification, and I'll talk a little bit more of that in a future slide. Solar is required with Title 24 now. HERS raters are part of your team. Leverage them, use them, and they will be a big asset for builders as well as installers of some of these new technologies. They can bring all kinds of insights to this process of providing comfortable, cost-effective houses that are very profitable to builders. On the envelope side, it's becoming a little bit more stringent, and there are some great websites that talk about the details of all the specifics. I'm just going to hit the highlights, and then we're going to delve, as Greg said, into the water heating elements of it. Mechanicals are getting more and more stringent as well, 30 to 35% more. Residential lighting, they're backing off a little bit. It's not as important. We've already done a great job there, excuse me, and we're seeing things level out as LEDs become more pervasive in all the new structures. Plumbing improvements are an interesting part of this whole element. They want to decrease the number of long, fat runs and shorten those up using skinnier pipe. Additionally, you're seeing the use of what they call power pipes, or pipes that harvest heat out of the drain lines coming out of showers and baths. So as we look to the future, gas is moving to electric on applications, so for both heating and water heating, and demand response will be one of the elements and technologies that we're going to leverage in electric water heaters, and electric heat pump water heaters specifically are a great solution there. Must be a little bit of a delay on the next slide. So I wanted to talk a little bit about what's going on in U.S. trends. Oftentimes we hear the statement of, wow, we're just finally hearing about electrification or how the grid is changing. The reality is, I want to take a little bit longer view. Cast your mind back to the 40s. We had a high percentage of coal and wood, actually, as part of our heating sources, for both, mostly for house, but also for some water applications. And as we see this move through the 50s and the 60s and the generation of new homes, we see that shift where the coal drops off dramatically, wood drops off dramatically, fuel oil peaks around the 1960s, and actually during the crises in the 70s, it dropped even more. The inflection is not shown here, but the utilization was still there. It's just people used less and suffered more during the winter, and their costs went up. And as you can see, natural gas has been on the rise, but there's a natural trend that's going down, even though we're having an expansion of gas territories. And all the while, we're seeing electricity continue to gain more and more prevalence within our building stock across the nation. So when we talk about a shift from gas to electric, this is not something new, and the grid and the housing stock is all shifting this way. For people in California, there were emissaries of this technologies dating back into the 50s with the all-electric home, showing wonderful living with this. And they had some challenges, but those have been resolved, and we're now seeing electricity being the mainstay for a lot of building applications, especially in single-family and multifamily. So, next slide, Greg. So one of the other things that's going on as we look at the grid is an increase in renewable generation. And this is a famous sketch that most Californians are somewhat familiar with, and I would hope everybody on the call would be very familiar with it. It's what we call the duck curve. And it shows what's going on with the load throughout the day, as well as the generation of renewable power. And this is mostly solar in this particular case. And it continues to get more and more, deeper and deeper belly into this duct. And so we want to take advantage of all this excess power. On a recent study that we did here in the Northwest in 2017 and 2018, we actually had 6 or 7 days during the month of June in both years where California was actually paying their neighboring states, Arizona, California, Oregon, and Nevada, to take power off their grid. So this is going to be a continued problem. This leads to where the future is going. If you're adding all this electrical load and then you have all this generation, how do you make that all work together? So there's several ways of doing it. We can turn off the PV or the wind. We have a lot more wind here in the Northwest, but that's sort of a wasteful use of that energy or that generation tool. Battery storage, very expensive, or flexible electrical loads. And we find that heat pump water heaters and certain kinds of building technologies for thermal storage are solutions for this. So as we get into the conversation a little bit more, I want people to have this mindset as we're getting more electricity on the grid, more utilization of electricity into the housing stock. We're seeing more renewables on the grid. How do we leverage both of those? And why is Title 24 changing to add more solar and adding more electrical usage? So next slide, please. So I wanted to give an example. This is a 1990s house built in Sacramento, and it shows in the 2020 version of the grid with current conditions, and it shows if you've got a mixed fuel versus an all-electric home. And what is the grid impact and what is the GHG impact of having those two styles of home? So it's the same home in 2020. As you see, everything keeps getting more and more efficient as you move through 2030 and 2050. However, the electric home gets more and more gets cleaner because the grid gets cleaner. Whereas if the grid continued to get cleaner, but you had a gas as part of your solution for both heating and water heating, you would actually not be able to see the same kinds of decreases in GHG contributions for that same house. So this same house built, no changes inside the envelope or inside the mechanicals, gets better and better over time if it's an electrical solution. Go to the next slide. This is a brief slide to just show you how space heating and water heating contribute to roughly 70% of the total energy use in a home, and that's for both single family, attached apartments, and even mobile homes. 20% about is what we have for a number for water heating, whether that's gas or electric. That's total energy use. And this is the area that we want to focus on, and this is one of the areas that NEA is focused on extensively. We think we can do a better job with the 20%, and that's my key area of focus. We've done an enormous amount of research on that, which will lead me to my next slide. So one of the questions that I'm sure everybody is asking is, okay, so with heat pump technologies, you're basically gathering heat from around the facility, around the water heater or outside the home and putting it inside the tank. So this is a very important study that NEA did with Pacific Northwest Natural Labs, and we had two side-by-side modular homes, and we had an electric resistance versus a heat pump and moved it around throughout the home to see what the impact was. The final impact, and there's a very long study, if you're welcome to see it, it's listed on this slide. It had modest impact during the winter. Spring and fall were kind of were neutral, and in the summer we actually saw an enhancement for that as far as cooling effect and also the reduction of humidity. Remember, in the Northwest, our summers are much more humid than in California, and they can be kind of spiky and hot at different times. So we found that this was an important study to look at. What was interesting is once we dug in a little deeper, the garage we saw no effect, which in our building stock area accounts for 20% of the application. I think in California it's higher than that. Most water heaters are in garages. In basements, which accounts for about 40% of the installation, it actually had no effect at all, and there was actually a benefit of reduction of humidity and or creating some dryness down there. Utility rooms, if there was sufficient size, which accounts for about 15% of the installations, it worked just fine. What we don't recommend is don't exhaust the cool air from a heat pump water heater onto a temperature or thermometer or temperature sensitive room, such as a child's room or into a bathroom where you may not want that cold air blowing on you. We also found that you don't need to vent these very often, and in a slide coming up shortly, I'll show you in California especially, you do not need to do that. Small localized effect while it's running, generally anywhere from 2 to 4 hours, and in California it'd be even less time. And the only thing that I would encourage you to think about is having sufficient makeup air to get into that water heater. This is a map of the West Coast, but I wanted to show the study we did was for the Northwest. A little complicated, but I would just use some basic colors here. The yellow area is what we call the maritime marine area, which is a vast majority of the west side of the Cascades. The green area is what we call an inland or more continental temperature. And when you look in California, the yellow zone goes down into California, and the green is only in Northern California. everything below the California-Oregon border is generally warmer and drier. So this does nothing but improve the results of a heat pump water heater in these particular applications. So the graphic or the chart on the left side shows on the west side in the yellow area, we saw only 5% of the time in a garage was the temperature at 42 degrees. 15% or 13% of the time in a garage was at 47 or above, and then 27% of the time was at 52, on and on and on. And then the blue line is what's showing up in the basement. So that's the percentage of time that they run at those temperatures. The reason I point this out is all heat pump water heaters on the market today, and especially the ones that Bradford White make, they all operate down at 37 degrees and they function just fine. So if you have any concerns about operating these things in garages or basements or in what you would consider cool spaces, we've proven that it totally has enough air or temperature to make up to create enough heat to have a positive experience for the customer. If you're worried about this being put into a cool space, put it in a hybrid mode. All heat pump water heaters today have a hybrid mode where if it gets a little too cold for the compressor to run, it will go on to electric resistance. Go on to the next slide. So one of the things I wanted to get out there is NEA has studied heat pump water heaters for more than 20 years. We've done detailed analysis on the savings. We understand what the interactive elements are. We've done well over 100 lab to field studies where we've run a test on a product in a lab, and then we saw how it was working with the customer and their draw patterns. These were randomly placed. They weren't just the friends and family. We also do performance testing on all the products that are listed on the qualified products list, and Bradford White's products have been on that list since the early 2012, I believe. So they're fully vetted. We have evaluation reports showing customer satisfaction as well as market uptake for the last 7 years. And then we often check on the original equipment manufacturer's reliability testing. And of course, Energy Star stands behind all of those products. So the only reason we have Einstein on there is he thinks we're ready to go, and I would agree with him. So the next slide, I think, is going to be switching over to you, Greg. Oh, actually, I forgot about this. I put this in at the last minute. One of the feedbacks that we get from our raters here in the Northwest is engage with more informed appraisers to talk about all the green attributes that your homes provide and get them labeled properly and show that the value of that certification. Insert a sleeve in the sleeve on the backside of the electrical panel, all those certificates, all the features and benefits that a homeowner should know about, and then point those out either to the real estate person, but better yet, give them a report so that they can include that in their RMLS listing, and then encourage appraisers to have the experience of evaluating high performance homes and show the value and benefit of things such as heat pumps and especially heat pump water heaters. So I think now at this point, I'm going to let Greg jump into everything he has about his particular solution.
Thank you very much, Jeff. And I know some of you are probably wondering, why is a guy from the Northwest talking to you about California changes? So I want you to understand that NEA is an organization that is probably the most leading in the whole industry, in the whole country, when it comes to utilities and management and figuring out the best solutions and then being able to execute promoting those solutions in the market. So their leadership in the Northwest is bleeding into other states. And that's why guys like Jeff Wicks are being called upon to be able to talk about the testing and the things that have been done around heat pump water heaters. This is not a new technology. And what you'll typically find is the guys that have been associated with this, Jeff being a little excluded, are the geeks that push into heat pump water heaters for 20 years. So they've had ideas, they've had thoughts about how this thing should work, And they have been influencers with manufacturers to get us to build these products, taking their experience into hand. So today I want to be able to talk to you about what Bradford White offers so that you too get heat pumped up. That's not just a quick and easy phrase. That's a phrase that should become very familiar with you. Some of you have not had much exposure to electric water heaters, but you have had a lifetime of exposure to heat pumps. The difference is they've just been called something else. Today, we think of heat pumps as being heating and cooling, which is it. That is part of it. But I noticed that none of you probably, if I walk in your house, have ice boxes any longer. You all have refrigerators. Well, a refrigerator is a heat pump. It's a compressor, condenser, and evaporator that says if you put something hot inside that box, its job isn't to make that food cold, it's actually to extract the heat that's in there. So it does so by using a compressor, condenser, and evaporator to absorb that heat, and then it releases the heat under the bottom of the refrigerator where that grill is and where the condenser coil is and a fan, and you feel warm air circulating under that refrigerator. That's the heat that used to be inside. This same technology has been adapted to a water heater using the same compressor, condenser, and evaporator. Those processes make this so much more efficient that we gave up ice boxes a long, long time ago. Freezers, dehumidifiers, bar refrigerators, window air conditioners, all of these are compressors, condensers, and evaporators. And I always will ask people that have question about this, and I'll say, look, they'll say, how reliable is it, Greg? And I generally look at them and say, well, tell me, the refrigerator that's in your garage that's got the beer and the soft drinks in it, how old is that? And usually the eyes begin to roll, and it's that was my grandmother's, and she gave it to me when I got married, and I've had it for 20 years, and I know she had it for 10 years before that. So it's about 30 years old. And I'll ask them again, and how many times has that been serviced during that time? And it dawns on them, none, never been serviced, because this is a very reliable, very proven technology that has been around, again, for a very long time. So the average home, as you count things up, 3 to 5 heat pumps already in place. To say that you're going to have a heat pump water heater really should not be that much of a challenge. So I want to give you a peek into what a heat pump water heater is and how it works so that there's no mystery around this. Sometimes contractors will say, I don't understand this, and I'll try to make it very simple and just show them. The heat pump water heater's job is to move heat rather than to create heat, but it actually can do both. Moving heat is the smartest way because using that compressor, condenser, and evaporator takes much less energy, and it's able to transfer that heat straight to the tank. But it also still has standard electric heating elements. So the promise of this product is to deliver the same volume of hot water that any standard electric water heater does, because it still is a standard electric water heater. Now, I want to make sure you understand that, because you're in a market where 90% of the homes have gas products in it, and most people have never had exposure to an electric water heater. So they don't know what to expect. It's fear of the unknown. So I want them to understand, and I want you to understand, this is a standard electric water heater. It's just smarter than the rest. It uses the heat pump to transfer heat when it can, but when it needs to, it automatically switches over to resistance heat so that it provides the same volume and has the same recovery as a standard electric water heater does. Now, the proof of the benefit of this is real simple and easy to see, and you can find it just by simply looking at the energy guides. Look at that. There's an energy guide for a standard electric water heater, and that's all standard electric water heaters today, because they all have a UEF of 0.93. That means they're about 93% efficient. So it loses 7 cents of every dollar when you heat water, but look at the Aerotherm. It goes from $419 a year to operate to $115 because it's using a combination of moving heat and creating heat, whereas the standard electric water heater can only create heat. That's the big difference, going from electric to electric and being able to save about $300 a year just by switching from one to the other. But now the next question is always, well, Greg, what about gas? And I'm like, well, gas water heaters are typically not as efficient as electric water heaters, but gas is less expensive, so people tend to pay attention again to the energy guide. But look at this, the energy guide on a 0.63 UEF gas water heater says it costs about $296 a year to operate, whereas Aerotherm costs $115. And then if you compare it with tankless, you have a very similar story. This product defines efficiency. This product says that because I move heat rather than just creating heat, I'm giving you about $3 in hot water for every $1 that you spend. I want that to sink in for a second, because that's really what's critical to understand about this. All of these other water heaters, all of the products that you've used your entire life are less than 100% efficient. Only heat pump water heaters can get above 100% efficient, and by doing that, save enough money that over time can actually pay for themselves. That's a real big deal. That's what defines this as one of the best of all of the green products that you'll ever see, is that it does pay for itself through energy savings. Now, to make this real easy, I always use the same messaging that we've learned from our utility companies for my entire life, and that's light bulbs. A heat pump water heater, when it runs, uses about 5.5 light bulbs worth of energy, because it's only using about 550 watts of power. 5.5 light bulbs. If you look at a standard electric, it uses 4,500 watt heating elements. And when they turn on, that's the equivalent of about 45 100 watt light bulbs in the house. Now think about that. I don't know about you, but my dad used to tell me when we left the room and we left one light on because that's all we had, turn it off. Imagine if in your house, every light bulb in the home came on all at once to simulate a water heater usage. Well, Aerotherm makes that very manageable when you're talking about only 5.5 when it's using the heat pump. So this makes it very, very easy and convincing to be able to show a homeowner why you're choosing to move from a gas tankless water heater to an electric heat pump water heater, because it saves you money. And it has so many advantages. It saves you money. It's manufactured by an American strong company that builds this in Middleville, Michigan. Bradford White is a company that's been around for a long time, and we build products that are made to last. We build for plumbing professionals. We don't make different grades of water heaters up or down the line for retail versus contractor. We only build for contractors, plumbing professionals that do professional installations. So this product is even backed by a 10-year warranty. Now you'll notice that most water heaters you've had in homes typically only have a 6-year warranty. 10 years says we're confident in this product. This is a change in the industry that says you should have confidence in a heat pump water heater and that this is going to last. So all the parts, compressor, condenser, evaporator, tank, all the electronic components, 10 years on all of those parts and 1 year in-home labor. And then it's a flexible product. It has 4 operating modes that it can operate with, and we'll talk a little bit more about those, from heat pump to resistance heat should it ever be needed. This is the first water heater installed in a home that says I have 2 means of heating water, which means that if something happens, I've got a hit by the bus plan. It can switch from heat pump to resistance heat, or it can switch from resistance heat to heat pump. And if something needs to be serviced, it's not very likely that the homeowner is ever going to be without hot water. So I want you to think about that and the benefits that that would provide for any home when a homeowner has that confidence in the product. So the only question you have at that point is to think about your thinking here is, why would you wait? Let's start saving now. And I get asked this question all the time because I travel the whole country for Bradford White, from one coast to the other, and people will see my shirt sitting on a plane and they'll say, what is this Aerotherm thing that you've got here? And I'll say, this is a heat pump water heater. And I might be saying it for the 15th time that day because of all of the presentations and meetings that I've done, but I never get tired of sharing the story. And when I tell somebody in the course of 4 or 5 minutes what a heat pump water heater does, how it works, and how it gives you $3 in hot water for every $1 spent, their response is always the same. And it amazes me. I need one of these. That's what they say. I want one. How do I get one? And it doesn't matter whether they've got a gas water heater or an electric water heater. It is always the same. Why wouldn't I want to put one of those in my house? And then I start talking to them maybe about the rebates that are available through the utilities, incentives to draw more attention to this technology, not because it needs a rebate. It just needs something to draw attention to it, to say this is different and different is good, and you need to put one of these in your house. So let's move on and talk about some of the common myths that you've probably heard about heat pump water heaters. And I hear this all the time, and my wife could tell you that I could say these things in my sleep answering these questions because there's nothing new under the sun. And it's always one of these, let's stump the water heater guy and tell them all the reasons why it won't work in our market. Some of them will say, well, gosh, it doesn't make enough hot water. And I have to remind them, the plumber that's saying this, if you look at the specifications on it, it has the same first hour rating as a standard electric water heater because it is a standard electric water heater. So when you've got 65-gallon first hour and it's the same spec, you don't size it, you don't change it. It's sized exactly the same way as any standard electric water heater. Some will say, well, gosh, it's challenging to install because it's a heat pump. And I have to remind them, this is the only heat pump that has top plumbing and electrical connections. Guess where they are on a standard tank? Same place. Nothing changes. And they'll look at it and say, well, but I need to know something about refrigeration. And I say, no, you don't. Not any more than you did when you installed your refrigerator in your kitchen. You plugged it in. It's a sealed system. It's not something that you have to know anything about as an installer to put in. Some will say it won't work in cold climates, and we know that that's not true as well. This will operate even in ambient air temperatures down to 35 degrees. There's heat in 35 degrees. So when you think about what type of climate you have in the home, under the home, in a basement, in a garage, as long as it's above 35 degrees when the water heater needs to run, then it's going to use the heat pump. But if it 2 o'clock, 3 o'clock in the morning, something drastic happened with the weather pattern, and it got really cold in one of your mountain climates, the water heater says, I may not be able to use the heat pump, but I still have the standard electric heating elements, and I'll just use those if somebody's up at 3 o'clock in the morning taking a shower, remembering that it's the coldest in the middle of the night versus the morning and the sun shining portion of the day. Some will say, well, they make too much noise. And I have to remind them the sound level on this is about 55 decibels of sound. And they're like, well, that doesn't mean anything to me. I'm like, I know. But think about what your dishwasher in your kitchen uses, depending on how old it is. Now, some of the newest ones that are out there, they get down into the high 40s, 47, 48. But a typical dishwasher is somewhere in that same range. And we'll talk more about that in a minute. So it's not one of those sounds that's real predominant. They say, it won't work in a garage because it's not a temperature controlled environment. And that's not true either, because your garage temperatures do fluctuate up and down. The water heater can compensate for that by switching its operating mode. And they might say, well, you must prevent condensate from freezing. Well, when it's that cold outside, water heaters typically in HVAC systems are not using or removing any moisture from the air. So there's nothing for it to freeze. It's a condensate drain line that comes off of this. It takes out a maximum of 2 quarts of moisture a day. So when it's that cold, if it was happened to be in the garage and some reason it got down into the 30s or 40s, the water heater says, I'm not removing condensation right now any more than your HVAC system is, so it's not going to have anything new happen to that. We already discussed the refrigeration technician side of this. Even for service, Bradford White takes care of helping to locate and to bring forth the servicers that we need, not just from the plumbing side, because the plumbing installer can do that, but also from any needs for repair to the heat pump portion of it. That could be a refrigeration technician. That could be your same plumbing company that's also an HVAC company. A lot of times we see those combined into one business. Any of those guys would be able to work on this. And we provide them with a 24/7 assistance to be able to do that. That's a Bradford White exclusive. We're the only manufacturer that does it. And then they'll say, well, they cost too much. And I have to look at them and say, you get all your money back on it. You get all your money back. The cost starts to become a little less relevant when a homeowner realizes that. Any technology that's not a standard tank or a standard gas water heater is going to be a little more expensive. They have been, but it's worth it because of what you get. You get your money back. You get a 10-year warranty versus a 6. So it's a longer life asset. And when you start factoring in some of the benefits that the utilities provide, it changes even faster into a quicker payback because of the incentives that you might be able to get. Now let's talk a little bit about how this actually works. Heat pump technology says, guys, when you start taking showers, the heat pump says, I'm going to kick on and I'm going to start recovering, because this water heater has electronic thermistors pressed against the tank. It actually is monitoring that tank temperature in 1 degree increments. And it knows when the tank temperature begins to fall that it needs to respond. So it responds by turning on the heat pump, and it says, I'm using 550 watts of power, and I start bringing that warm air across the evaporator on the top. I attach that heat to the 134A refrigerant, and then we compress that gas to boil it and make it hot. And then we wrap that hot condenser that contains all of that heat, hot enough that it would burn you if you touched it. We wrap it around the outside of the water tank, under 2 inches of insulation. Now we push this through a design that says we're going to take the hottest part of that gas all the way to the bottom of the tank where the dip tube is pushing the cold water in. And we do that so that we can have a balance in the tank that is not easy for most manufacturers to achieve. When we do it this way, we are attacking the coldest water with the hottest part of that gas. We then move that wrap up and down the tank, and then we recycle and do it all over and over and over again. Now, we still leave the standard electric heating elements in there so that if that 13-year-old jumps in the shower and says, my job today is to use every drop of hot water that's in that tank, and I'm going to drain it because I can. Then the water heater says, I'm smart enough to watch that tank temperature drop. I'm measuring the ambient air temperature to know when to do this, and I'm following an algorithm that says, now it's time to turn the heat pump off and to respond just like an electric water heater does by using those same elements. So it turns on the upper heating element at 4,500 watts, just long enough to satisfy that top third of the tank. Then it turns that element off and goes to the bottom heating element, which is a 4,000 watt, and it brings it on with the heat pump at 550 watts to recover the bottom 60 to 70% of the tank, actually just a little bit quicker than a standard electric water heater does. That hybrid mode is built in. There's no programming. There's nothing necessary for an installer to have to do to make that work. They don't have to understand anything other than wire it in, turn it on, fill it up first, turn it on, and let the water heater initiate its starting cycle, and it's factory set at 120 degrees, ready for the homeowner to change it to whatever temperature they want to put it at. Now, these are 220 volt products, so you do have to make a change in what you put in as an electrical requirement. In Title 24 is already specifying that you have to now put in, if you don't put in a dedicated 220 volt line, which is what I would recommend you do. You remember, this is kind of like when tankless went to a recommendation and then became required. You know, putting a 220 volt line in is in preparation for the future. So one way of making that easier under this requirement is to say, put in a 125 volt, 20 amp electrical receptacle, but make sure that it has the extra wire in that same box ready to go, so that if in the years to come, somebody needs to convert it, and it has to be marked in the panel box, and it should be marked even at that receptacle so that somebody knows that there's more behind the cover than they can see, to know that it's going to be able to change that over and actually direct wire the water heater right in if they should switch to a heat pump in the future. So my recommendation is go right ahead and just put that 220 volt line in and get credit for it if you're not already going to be using a heat pump water heater. Now, this product is going to provide some flexibility at your fingertips because it's not like a standard electric water heater. It's not like a standard gas water heater. This is an electronic water heater that says, I have operating modes that can be changed. I've got a temperature control on the front that says you can change me from 100 to 140 degrees simply by pushing those arrow up buttons or arrow down buttons and hitting enter. And this water heater says that when that tank turns off the compressor or the heating elements and it's quiet, that it's satisfied the thermostat, we guarantee that the water in the tank will be within 3 degrees of what the temperature says on the front of the tank. And that's because of the use of electronic thermistors rather than some of the crude thermostats that have been used in the past on water heaters. So this is a definite improvement. You can put it in the heat pump mode. That's where it's solar friendly. 550 watts of power. That's all it would be drawing from the solar panels on the house. And now you have a water heater that says I can run under all kinds of conditions just using the solar panels. I know that there's some homes in the market right now as a result of some of the fires and the things that are happening where they're saying we're cutting the power off. Well, if somebody had solar panels on that house, they would actually still be able to use this water heater. I mean, you can imagine families are scrambling and they're going bananas trying to figure out, what am I going to do if I can't take a shower? Well, this is one way to fix that. The hybrid mode is where it's both a heat pump and a resistance heating water heater, and it switches back and forth on its own algorithm, deciding what it needs to do based on the usage. The standard electric mode is there as a backup so that if anything ever happened to the water heater, it's going to be to the heat pump, it would switch automatically to the standard electric mode. So now it still provides hot water. It would then diagnose itself, put a fault code in the display, and beep to get the homeowner's attention so that they know something has happened. That way they know to make a phone call, but they still have hot water as a result of having a redundant system. It's got a vacation mode, so if you're going to be gone up to 99 days, you can tell the water heater, I'm going to be gone. I need to be able to turn this thing off. And then if you were going to be gone for 2 weeks, you'd set it up for 14 days. The day before you come home, it would automatically turn itself back on so that you'd have hot water waiting for you when you walk in the door. It also has a communication port on the front of it. This is used to test every single water heater in the plant in Middleville, Michigan, so that we have 100% quality control, knowing that a water heater does not leave the plant until it's been verified. This device allows us to put a computer on it and scan every wire, every plug, every switch, turn everything on, turn everything off, and we know with certainty, 100% certainty, when it was put in the box, that that product worked exactly as it was supposed to. That is also going to be used for communication with utilities as well, and we're working on our system to enhance that right now so that utilities in the future, as they want to be able to make changes to some of these products and send signals, we're going to be right there in the game with the same technology. Where can they go? These are some pictures that I just collected off the internet of various products being installed across the country, and as you can see, they can go in all kinds of places. They can go in attics, they can go in basements, they can go in laundry rooms. Laundry rooms are actually one of the best places to put them. If you think about it, you've got a dryer and a washer in a laundry room. That dryer is a heat producer, and it also is moisture that's coming out of those clothes. So the laundry room is usually the warmest, most moist room of the house. And if a water heater is sitting across in a closet with a louver door in front of that, then that water heater says, I'm loving the heat that's coming off. You're making me operate in a higher efficient means at that point because of that. And I'm also off-gassing some air that will make that laundry room just a little bit cooler when the water heater runs. So you can see all of the places that they can go, and you can see the different configurations. Bradford White is the only manufacturer that has the plumbing connections on the top. That is an exclusive feature just for us. That means it installs very clean, and it goes in the same place as any other standard electric water heater or gas water heater would have gone. And it makes it very comfortable for the plumber to do that. So where are the best locations? Well, a basement if you've got one, because now you've got free heat because the earth is a giant battery that says I'm putting off 50 to 60 degree air. Laundry rooms, as we just talked about, because they're warm and damp already. And they may be next to the HVAC product, which means the condensate line coming off of this that says I'm going to remove up to 2 quarts of moisture a day, and I need a place to drip that water. Tying it to the HVAC, it's not acidic like a tankless water heater. It doesn't have to be neutralized, doesn't have to be touched in any special way, and it can be tied straight to the HVAC. It can be dripped in a laundry drain, any of those places. The garage, which is a non-conditioned space that stays above freezing, is a perfect spot to put it. You're going to have to carve out some space in that corner. Once again, I know most of you have gotten away from that over the years, and now you're scratching your head and saying, well, how are we going to do this? Excuse me. Put it back in the corner. We need about 7 inches space around this water heater. That's for serviceability and to make sure that it moves air the way it's supposed to. If you need to elevate it, that's not a problem as well for both the 50 or the 80 gallon as well. It's going to be a little less efficient if it gets colder, but it's going to be more efficient in the summertime when it comes back up, and they generally average themselves out between the cycles of winter versus summer. A closet, you can put a 50-gallon heat pump water heater in a closet with a 36-inch space. That gives the 7 inches around it so that it's not pushed right up against the wall. The earthquake straps can still be attached with some spacing behind it, and there are some ways that plumbers have already figured out how to do this, using some standoffs with the metal brackets to be able to hold the water heater out 7 inches very quickly and easy, and I can share that with you as well. But it does need a full louver door in the front. That's going to make sure that we've got enough air coming in. Off-the-shelf, top-to-bottom louver door is all that it requires. Now, we mentioned earlier as well something about the noise level, and this is the proof of that. This just gives you an idea, looking at this, how much 55 decibels of sound would be. All the manufacturers are somewhere in this same range, but it's about the same sound level as a dishwasher. You know, when you look at the fact that a typical whisper is about 40 decibels, you know, the sound level of a heat pump water heater is very difficult to detect for most people unless you're standing right beside it. So in summary here, I want you to think about this, the added value to the home that a green package adds for the higher appraisals, as Jeff mentioned. Get that recognition, get that appraiser in there that understands what he needs to do to get you credit for these extra things that you're putting in. And remember, a heat pump water heater, because it's electric, emits no greenhouse gases at all. This is one of the safest and best products from that perspective to be able to put in for the environment. It can help your indoor air quality through dehumidification, depending on what part of California that's in. In some areas, that's more important than others. It's solar friendly, and that's a real big deal since starting next year, you have to put the solar panels on the house. Think about the fact that in the heat pump mode, 550 watts is all this draws. Educate that buyer on what that means and being able to use what's with solar panels and to have water, hot water that they got from the sun for free. It pays for itself through energy savings alone. And that's the one big thing that I want you to remember. All other forms of heating water, less than 100% efficient. Heat pump water heaters, above 100% efficient. You have to be above 100% efficient to have a payback. Plain and simple. It gives you more than it takes by moving heat rather than creating heat. Let's avoid the dangers associated with gas. I know here in Kentucky, where I am, we just had a gas line explode yesterday, one of the main lines, and somebody was killed, unfortunately, as a result of that. So let's stay focused on all of those things that can happen, and when you put a heat pump water heater in, you avoid those dangers. Exclusive 24/7 technical assistance. This is part of Bradford White's promise to all 50 states that we're open 24/7, that if anybody has a question, that if any installer, any homeowner, any contractor, they can call a dedicated heat pump water heater line or our technical assistance line, and we're here to help. We're here to help you as a builder. We're here to help your contractors to make sure that they understand everything they need to know about this. And finally, the Bradford White Advantage Package. With the Advantage Package, what I'm referring to is the services that we provide and that I will provide. You're going to get in-person training for your plumber. Plumbers don't know anything about heat pump water heaters. I don't want them to read something and try to figure it out. I don't want them to look at the drawings and the pictures and try to figure it out. I want them to be 100% convinced that this is the right technology. I want them to understand how it works, how it should be installed. I want to provide in-person sales training for your teams, your sales teams. You've got model homes with people in it that are going to talk about whatever's in that house. I want them to understand exactly how this product works and to be able to speak to it. And as you've learned already, it's not as complicated as people thought they were. Once you get over that perception, once you understand that it operates just like the refrigerator in your house. And then I want you to talk to me about getting an aerotherm in your model home, because having a product there where homeowners can see it, it becomes a feature of the house. It's not something they're used to seeing, so it's going to draw their attention. And with any POP around it that explains something about what it is, and with your in-house people talking about how it moves heat rather than creating heat, and how it only uses 550 watts when it's in the heat, using the heat pump to heat, and that it can take that tank all the way to 140 degrees using just the heat pump. And that's exactly the way I have mine set up here in Kentucky in my house year-round with heaters in my garage. So I want them to have that full understanding of how this thing works. So I want you to be the early adopter. That's what I'm asking you for. I want you to think about being the first to put these in and to have a project out there. I want you to attract buyers who want this now, because there are a percentage of people in every market that are looking for the latest and greatest and the newest thing. I want you to be educated and educate them on how heat pump water heaters pay for themselves. And I want them to recognize that this is smart for you and it's smart for your customer. Now, we partnered with NIA and also with Green Builder magazine to be able to put together a really good training program and educational effort where we're using the Title 24 ebook that I think all of you probably already got, but if you didn't, you can go to Green Builders Media website or Bradford White and pull that down. That's free. We're running radio spots right now that'll run through the end of November that are targeting, educating people on heat pump water heaters, targeting you as builders, but homeowners as well, to say, I at least know the words, I understand what it does, I understand how it saves, and I'm familiar at least with that term. They weren't familiar with tankless gas water heaters when they first started arriving in your market, and we had to teach them about that. Now we're going to teach them about heat pump water heaters. And we've also got 2 boot camps that we're going to be offering coming up here before long, where we're going to be in Temecula at the Pechanga Resort doing a panel discussion there. Jeff Wicks and I talking about this technology to anyone in attendance. And then we'll come back again in November to the Southern California Builders Association in Irvine, California, and do even more. We want to open the door for you to bring anybody, everybody from your office and your organization to come in and learn about this technology. I've got salespeople that are there in Northern and Central California. Rep West and Tom Alkire, he's going to be your contact, and we'll make sure that you have access to this information. And Jeremy Crane with Signature Sales in Southern California. These are my boots on the ground in your market, and trust me, these guys are on fire for heat pump water heaters. They're out there talking every single day about the changes in California and how important heat pump water heaters are to your market. So please use them, use me, email me, call me, reach out to me so that I can help and do webinars for your team if we need to make sure that you have all the information that you need in order to feel comfortable using heat pump water heaters. This is your time, California, to get heat pumped up. This is your time to learn about an amazing technology, and let's get out of the age of ice boxes and let's get into the age of refrigeration and moving heat into a product that says, I give you more than I take and I pay for myself through energy savings. That's what this is all about. This is a no-brainer, easy thing to be able to do that just makes sense because of all of those reasons. So it has been a pleasure being able to talk to you. Now we're going to open this up for questions, and we're going to bring Jeff back on as well.
All right. Thank you, Greg. Appreciate it much. Like you said, go ahead and send in your questions via the questions box. We've already got some in there. We're going to start with one from Douglas. Greg, he wants to know, do you have a water heater product for small commercial kitchens?
Product that we have right now is a residential product. We've got it in a 50, and we soon to have our 65 available, and in an 80. I don't have anything right now that's for commercial, but you never know what you might see in the future.
Okay. Wanted to get to a question from Ryan. He wanted to know, does the water heater need earthquake straps in California?
As California, I believe, does require that. If I'm remembering correctly, earthquake straps are necessary in most markets on the West Coast, and there are different ways that can be handled by blocking 7 inches behind the water heater or using standoffs with one metal bracket across it at the top and the bottom. Push the water heater up against it, and then you use those straps right around it.
Okay. Greg, we got another question for you. This one is from Jeff. He wants to know if the water heaters can be installed on the exterior of a home in Southern California.
As long as the water heater is not exposed to the weather. Oh, I'm sorry. Was that to Jeff or was that to Greg?
No, I'm sorry. The question was from Jeff. It's to Greg.
Okay, I'm sorry. Okay. As long as the water heater is not exposed to the weather. If on the outside of a house, somebody built a shed that protects it, and they said, that's where my water heater has always been, that happens sometimes in Florida as well, and I've seen that. As long as it's not exposed to the rain, where it's going to get weather exposure, then we're okay with it being outside. You're still going to, it's like putting it in a garage, but it does have to have some protection that keeps it out of the weather.
Okay. We had a question from, let's see. Oh, yes, there was a question from Douglas early on. He asked if you could provide a little more detail on the smaller pipe size. And it's been a while since he asked the question. I honestly don't remember if it was during the end of Jeff's part or if the beginning of Greg's part. But could you address it was Jeff's part. Okay, Jeff, can you address that part about the smaller pipe size?
Sure. So part of Title 24 is you get additional credits and points for keeping the distance and the diameter of your pipes. We always want to remember we want to maintain the customer experience, but if you can put the water heater near the points of use or in a column within the house, that's going to reduce the number of feet. So don't run a long, big fat pipe to the far end of the house and have that thermal loss all the way across that. I would say, I think it says the main trunk has to be no more than 10 feet long, and I think it's 3/4 of an inch, and then they suggest going down to 1/2 inch and even 3/8 for the water.
Somebody's probably going to ask as well, can I use a recirc pump? And the answer is yes. You treat this just like any other water heater, but you use a smart recirculating pump. You don't want a system that says, I'm going to maintain 120 degrees in these pipes 24/7, just in case somebody decides they want to turn a hot water line on to take a shower. You want a pump system that says, I either have a motion sensor in the furthest bathroom, or I have a switch that somebody pushes, a button, or I cycle based on a timer that says in the morning at 6 o'clock, we know people get up and start taking the showers because they said that. So at 1/4 we're going to recirc that line one time. And then we might do it again at 4 o'clock in the afternoon when they come up, or in the later evening time. Just make sure it's not one that continuously runs. You don't realize it, but if you do that on a standard water heater, it runs all the time, and a heat pump water heater would do the same.
Okay. We had a question from Ryan. He wanted to know, what are some of the non-energy benefits of these heat pump water heaters?
Greg, do you want me to take that?
Yeah, take it.
So some of the non-energy benefits that we see here in the Northwest and across the country, for that matter, is you're a much more attentive or a reasonable person for the grid, because instead of slamming on, as Greg pointed out, 4,500 watts for 15 minutes, you're adding the equivalent of about 550 watts over a longer period of time. So you don't get the spikiness and the peakiness. And what happens, especially in California, people get up in the morning, they'll take a shower, and then you have this huge inrush of load from hours of 6 to say 9 in the morning. And then after that, you have a reduction. The benefit of on the grid side of it alone is that the water heater is going to spread that load out over a period of time and take advantage of some of the solar gains that are happening starting at about 10 o'clock. The other side of it is you're not burning natural gas, which has NOx and SOx, as well as indoor air quality and potential hazards to the homeowner and or to the community. So by not having natural gas on site, you're able to reduce those exposures and the dangers of natural gas. Those are just two that I can think of.
And you can also, I mean, if you came to my house in Kentucky, you would see that my heat pump water heaters every day of the year are in heat pump only mode. And that's because, like most Americans, our shower patterns are, we take showers in the morning and then we get up and leave. And when nobody is home in my house, and a lot of houses are like that, people go to school, they go to work. So a heat pump water heater takes a little longer to recover when it's in heat pump only, but if the house is empty, who cares? It's only using 550 watts of power, and instead of running an hour, it may run 2 or 3 hours to satisfy that tank. But that's only a 0.5 kW draw times 3. It uses 1.5 kilowatt hours of energy, and that's it. So you learn, as most of us did growing up, tankless water heaters didn't exist, and we knew when to get out of the shower because somebody yelled and said, you better get out of the shower because you're using all the hot water. This is that same adaptation. You can't take showers forever, and you use the water that you have, and you properly size the tank to the house. So if they need a 50, you put a 50 in. If they need an 80 or a 65, you size it according to the number of bedrooms, bathrooms, following the code. And if you do that, people do not routinely run out of any tank. They just don't, because it's properly sized. A few times a year with extra guests you might, but otherwise you don't. But being able to operate it in heat pump only mode, I have the satisfaction of knowing I never use more than 550 watts of power.
All right. I know that we're at the top of the hour, but we've got some great questions. We're going to press on here. Greg, I had a question for you. When you talk about this paying for itself, what kind of time frame is that on?
Well, that depends on the market that it's in and how much the cost of electricity is. On an average, what you're seeing in those energy guides is at about 12 cents a kilowatt hour, and that is the national average. So it's saving about $300 a year over a standard electric and a little less than that over a gas. So when you start adding that up over the course of a 10-year warranty, in most markets, that adds up to about $3,000. And that's a product that in most markets, California is going to be a little different because your cost of kilowatt hour is a little bit higher. But depending on the rebates that are available, a lot of times a homeowner could see payback in 5 or 6 years. But with a 10-year warranty, that doesn't mean it expires at 10 years and it just stops working. That means it continues to save and put money, giving you more than it takes every single year for as long as it lasts.
Gotcha. We have a question for Jeff, and it has to do with the comment you made earlier about residential lighting. You said California was kind of backing off a little bit. Can you explain exactly what you meant by that? Are they lowering the efficacy requirement, or what did you mean by they're backing off on the residential lighting?
I'm sorry if I misstated that. If they're not backing off on it, they're just not having as heavy an increase as they've had over the last 5 years. So they are requiring occupancy sensors, and they're also wanting so many lumens per watt. So they're still there, but they're just not asking you to get that much better. We've stabilized that one. We've done a great job with LEDs. So I would say if you're putting in occupancy sensors and you've got a good lumen per watt ratio, you're going to be in good shape.
Gotcha. Okay. Wanted to get to a question from Avery asking about large multifamily installations. So you've got a big question right now when it comes to large multifamily structures. AHRI has no large heat pumps certified. The question is Bradford White working on such large capacity models? And to go along with that, is there any communication with AHRI about some kind of protocol that can be created for certifying them?
Well, Bradford White is always a, yeah, I'll let you take part of that, Jeff, because I know you look at the industry as a whole, if you want to.
Sure. Yeah, I'm not going to speak for Bradford White, but the whole world of multifamily and low income water heating is exploding. In the Northwest, we're seeing lots of projects go in that are using heat pump technologies for centralized systems, and the efficiency factors are phenomenal, especially over electric resistance, but also over natural gas boilers. And we are seeing products come in. I would say that all three of the big residential manufacturers of heat pump water heaters are not playing in that space. The people that are the folks like Colmac or Nile or even Sandon. But I would say that there are significant improvements in this area, and stay tuned. We're going to see some standards come out about this. I was just at a workshop, and lots of people from California were saying, how are we going to build a standard? What is AHRI going to do? And AHRI is just starting to look at this, and they are starting to create some testing methodologies. We're going to be giving them some guidance and some understanding that we've done. There's a contractor here in the Northwest who's installed well over 50 of them and has some valuable lessons learned. And from his perspective, they are saying, we're not ready yet, even though we've done a lot of these over the last 5 years. So stay tuned.
A lot of the older building stock used individual water heaters or even banks of water heaters, and those could be replaced in some cases with a heat pump water heater. When you get into the true commercial side, Jeff correctly stated, the residential manufacturers have not released anything in that space just yet. We want to make sure that we get the residential space conquered.
All right. Wanted to make sure to put the final call out there for questions. Please send those in via the questions box. Ryan wanted to know if builders need any special training to either handle or install these, and I'll throw in a follow-up question to that. Do homeowners need any special training?
When it comes to installation of a heat pump water heater, it is exactly the same as installing any other tank other than the space consideration. What you're going to be looking for is to make sure that you have the 700 cubic feet of air around the water heater that it needs. Now, that can be accomplished in a closet with a louver door, or it can be accomplished just by being in the garage itself where you have more than 700 cubic feet. Cubic feet, not square feet. That's a 10 by 10 by 7 area. When it comes to installation, it's a hot and a cold water line, it's a condensate drain, and it's a 30 amp receptacle, 30 amp requirement, just like a standard electric water heater would be. Most plumbers have had at least some experience with that, or at least are familiar with that portion of it. With us having a product where the connections are all on top, just like they always have been, it makes it very easy for a plumber when he does his first installation to say that wasn't tough. That wasn't anything like what I thought it was going to be. They all have misconceptions about it being HVAC, and they have to know how to charge something, and that's just not the case.
Okay.
So the only thing I would add to that is that the homeowner will need to keep an eye on the enunciation panel and monitor the air filter, because air is flowing across the device, but they will get plenty of notification, and it's not mission critical. It just will say, hey, it's time to clean your air filter, like you do for a furnace or for anything else. So it's just a matter of taking that out, washing it off in your sink, and putting it back in. It's not a lot of effort.
Wanted to get to a couple questions from David, if we could. He wanted to know if it can be programmed for time of day operation, so similar to like what a thermostat would be.
So right now,
no.
Yeah, I was going to say right now, no, but that will be added as a feature starting early next year with some of the new products available. And time of use rates are very critical in California, especially, but across the country as we interject renewables onto the grid.
We're working to enhance the Wi-Fi abilities of this water heater, and we will be releasing some of those features this next year. But that is part of what we're looking at. I mean, that is a requirement for a lot of utilities to be able to do some programming. So that would be one of the things that we're working on.
All right. Well, speaking of programming, David's other question was, can it be programmed to remain in heat pump mode even when the tank is depleted?
If you put it in the heat pump mode, yes, it is going to just use the heat pump operation if you tell it to go there.
All right. Well, I don't see any other questions, gentlemen, so I am going to go ahead and wrap it up. And thank you both for sharing your time and your knowledge with us today. And thank you to the audience for asking great questions. And thank you to Bradford White for their generous sponsorship today. We're going to see you back here in just about a month. It'll be Tuesday, November 12th to be exact. We're going to be talking about residential fire sprinkler systems with Uponor. Won't you join us at our usual start time of 2 p.m. Eastern? Until next time, enjoy the fall colors in your area, whenever it is that they might pop up, and have a safe and happy Halloween. Take care.